Your infrastructure is growing, and with it, so is complexity. More microservices means more secrets, scattered across environments, pipelines, and teams. More internal and external services means more TLS certificates to track and renew. And with the 47-day mandate on the horizon, the risk of outages due to missed renewal is real. Meanwhile, your engineers need access to production servers, databases, and clusters, and they're getting it through static credentials and ad hoc workflows. You're managing all of this with brittle, disconnected tools that don't give you centralized control, automation, or the security guarantees you actually need. That's the problem Infisical was built to solve. Infisical is an open source platform that was built for secrets management, certificate management, and privileged access management. You can self-host it on your infrastructure for full control, or use Infisical Cloud to get started immediately. Trusted by companies like NVIDIA, OpenRouter, Volkswagen, LG, and UPS. Infisical gives developers, infrastructure teams, and security teams the tools they need as infrastructure complexity grows, all under one roof. In this video, I'm going to walk you through how each of these products works within the Infisical platform, so you can see how teams are managing certificates, secrets, and privileged access today. Let's start with secrets. API keys, database credentials, environment variables, certificates, encryption keys. This is the sensitive data that your applications need to run. Without proper management, they end up hard-coded in source control, stored in .env files, copied into CI systems, and shared across teams. They sprawl across environments, dev, staging, production, with no clear ownership, no rotation, and no visibility into who or what accessed which secret and when. Let's look at how Infisical handles that. Secrets are organized by project and environment, so you can clearly separate development, staging, and production. Within each environment, you can structure secrets using a folder-based hierarchy. This is useful for grouping secrets logically, be it by service, application, domain, and then applying scoped access controls at the folder or environment level. That means you're not just dumping key value pairs into a flat list. Every secret is versioned, so when a value changes, you can see exactly what changed, who changed it, and when it changed. And if something breaks in production, you can roll back to a previous version with point-in-time recovery. This turns secrets from scattered configuration into a structured, auditable system of record. Now, storing secrets centrally is step one. The next question is, how do these secrets securely reach systems that need them? Infisical integrates directly into your existing infrastructure and workflows. For Kubernetes, you can integrate with ESO, or use the Infisical Kubernetes operator, CSI driver, or agent injector to inject secrets directly into pods, without hard-coding values into manifests. For infrastructure as code, Infisical ships an official Terraform provider. This is available on the Terraform registry, so you can manage and reference secrets, projects, environments, and identities directly as Terraform resources. There's also an official Ansible collection on Ansible Galaxy, letting you fetch and inject secrets straight into your playbook. And for Pulumi, secrets can be securely referenced at runtime as well. For containerized applications, Docker environments, or local development, you can use the CLI. For example, Infisical run npm start. This injects secrets into your process at runtime without writing them to disk or committing them to source control. No .env files needed. For longer running services or VM-based workloads, the Infisical agent can handle renewal and retrieval automatically in the background. For application-level integration, Infisical offers SDKs across major languages, so your services can securely fetch and use secrets programmatically. And beyond runtime injection, Infisical supports over 50 secret sync integrations. And secret syncs mean you can automatically push secrets into GitHub Actions, Vercel, GitLab CI, AWS, GCP, Azure, and many other platforms that require environment-level configuration. There's a supported approach for virtually every use case. And if your setup requires something custom, Infisical exposes a comprehensive REST API so you can programmatically manage secrets however you need to. This allows Infisical to act as a single source of truth, while securely distributing secrets to the platforms and tools you already use. Now, let's talk about eliminating long-lived credentials altogether. Now, even with centralized storage, long-lived credentials are still a risk. If a database password lives for months or years, it only has to leak once. The first line of defense is automated rotation. Infisical can rotate credentials on a defined schedule, database passwords, IAM credentials, and other secrets without human involvement. This is especially important for third-party SaaS APIs, legacy systems, or services that don't support fine-grained IAM. Not everything can issue short-lived credentials, but rotation still ensures that they have a short, limited window of exposure. Where your infrastructure supports it, dynamic secrets take this even a step further. Instead of rotating a static credential on a schedule, Infisical generates a unique ephemeral credential on demand, a short-lived PostgreSQL credential with a defined TTL, or temporary AWS IAM credentials that eliminate permanent shared keys entirely. You can use both, rotation for systems that need it, dynamic secrets where the infrastructure supports it. Either way, you're moving from long-lived trust to time-bound credentials, and that dramatically reduces blast radius when something goes wrong. And centralization only works if access is controlled properly. Infisical provides role-based access control, so permissions are assigned based on roles, not individuals. Access can be scoped at the project level, the environment level, or even the folder level. That means a developer might have read access in the development environment, but not in production. Security teams can define clear boundaries without slowing down engineering. And for sensitive environments like production, Infisical supports approval workflows. Changes to secrets can require review before they take effect, preventing accidental or unauthorized modification from affecting production systems. And every action is logged. You get a comprehensive audit trail showing you who accessed what, when, and from where. That turns secrets management from an operational convenience to a governed system of record. Even with strong management practices, secrets still leak. They get committed to Git repositories, logged in CI pipelines. Infisical CLI includes a scanning feature that detects over 140 secret types in your code base. You can install a pre-commit hook, so if a developer tries to commit code containing an exposed credential, the commit is blocked before it ever reaches source control. And for an additional safety net, Infisical's secret scanning product continuously monitors your repositories across GitHub, GitLab, and Bitbucket, catching anything that slips through. That's secrets management done properly. But credentials aren't the only thing that your infrastructure needs to keep track of. Certificates are what allow services, devices, and users to verify each other's identity, establish encrypted communication, and ensure data hasn't been tampered with in transit. Every HTTPS endpoint, load balancer, service mesh, and internal API using TLS or MTLS depends on them. The problem is that certificate management is usually fragmented and manual. Certificates are issued by different teams. Renewals rely on scripts, reminders, or manual coordination that can take weeks per certificate. Most organizations don't have a clear idea of which certificates are issued and what endpoints they're on. When a certificate expires unexpectedly, production goes down. But outages are only a part of the issue. Without centralized control, you lose access into who issued what policies were applied, and whether certificates have been revoked. And the cumulative time spent coordinating renewals across large certificate estates is enormous. Infisical combines what most platforms split into two products, PKI and certificate lifecycle management. Let me show you how that works. The core of certificate management is the certificate authority, the entity that issues and signs certificates. CAs can be internal or external, public or private. Infisical supports all three use cases. A built-in internal CA, integrations with external CAs like DigiCert or Let's Encrypt, and integrations with external private CAs like Microsoft ADCS and AWS Private CA. We'll cover these CAs now. Let's start with internal. With Infisical's internal CA, you can create root, intermediate, and issuing CAs directly within the platform, establishing a proper certificate hierarchy. If your organization already maintains an offline root CA, you can use Infisical specifically for your intermediate and issuing CAs alongside it. And beyond creation, Infisical lets you manage the full CA lifecycle, including renewing and revoking CAs. Each CA maintains its own certificate revocation list, so you have a clear record of which certificates issued by that CA have been revoked. Now let's talk about external certificate authorities. Not every certificate needs to come from an internal CA. Many organizations rely on a mix of certificate authorities. Public CAs like Let's Encrypt, DigiCert, Google Trust Services, and Zero SSL, and external private CAs like Microsoft ADCS or AWS Private CA for internal infrastructure. Infisical integrates with all of them, acting as a centralized layer that connects to every CA across your enterprise. Regardless of where a certificate is signed, issuance goes through Infisical in a standardized way. You don't have to replace your existing CA infrastructure. Whether certificates come from Infisical's internal CA, public CA, or an external private CA, they're visible and governed in one system. Now that we've covered CAs, let's talk about Certificate Lifecycle Management, or CLM. This is where you go from having CA infrastructure in place to actually issuing, managing, and delivering certificates across your organization. If you're onboarding onto Infisical with certificates already deployed into your infrastructure, the first step is discovery. Infisical can scan your infrastructure and inventory the certificates that are already out there, so you know what you're working with before you start issuing new ones. From there, the enrollment workflow follows a clear structure. First, you define a certificate profile. This is the configuration that specifies the issuing CA, the certificate policy, and the enrollment method for a given group of end entities like web servers or internal services. Certificate policies restrain what can be requested, things like allowed name formats, key algorithms, maximum TTL, and usage constraints. This ensures issuance follows consistent, enforceable rules rather than ad hoc requests. Then you select an enrollment method. Infisical supports API-based issuance, the Acme protocol, and EST. So whether you're issuing certificates through a dashboard, an Acme client like CertBot, or an EST client for IoT or enterprise devices, there's a supported path. And once certificates are issued, they need to reach your infrastructure. There are two models here, pull-based and push-based. In a pull-based model, the client fetches the certificate. An Acme client like CertBot writing directly to your server configuration. Cert Manager configuration, Kubernetes requesting a certificate and writing them directly to a Kubernetes secret. An EST client pulling to a device. Or the Infisical agent retrieving certificates on behalf of your services. In a push-based model, Infisical syncs certificates out to external destinations, like AWS Certificate Manager, Azure Key Vault, or other cloud certificate stores. This way your infrastructure stays up to date without clients needing to request anything. Renewals work across both models. Client-driven renewal is pull-based. The client monitors expiration and requests a new certificate when it's approaching. Server-driven renewal is push-based. Infisical automatically renews certificates before they expire based on a threshold that you define. Then it delivers them downstream. And if a certificate is compromised or no longer needed, it can be revoked centrally and then added to the certificate authority's certificate revocation list. The idea is that Infisical gives you all these structures and tools, profiles, policies, enrollment methods, delivery options. You can orchestrate these and fit them into your infrastructure in whatever way your environment requires. Every certificate requested in Infisical creates a certificate request object, giving you a clear record of what was requested, by whom, and against which certificate profile. Once that request is processed, the resulting certificate appears in the certificate inventory, a centralized view of every active and expired certificate across your organization. You can filter and search across the inventory to find exactly what you need. For sensitive environments, issuance can require approval, ensuring certificates aren't created without the required oversight before the request is processed. And to make sure nothing slips through the cracks, Infisical provides alerting for certificates approaching expiration, so your team is notified before an expiry becomes an outage. Now that covers secrets and certificates. The next product in the Infisical platform is privileged access management. When someone needs access to a production database, when they access a Kubernetes cluster, when they SSH into a server, that access needs to be authenticated, authorized, time-bound, and audited. Instead of distributing static credentials, Infisical centralizes how privileged access is granted, injected, and monitored. Here's how that works. At a high level, Infisical decouples user identity from infrastructure credentials. Users authenticate using their existing identity provider, SSO via SAML or OIDC. They never receive or store the underlying database password or SSH key. Infisical handles credential injection on their behalf. The workflow starts with discovery. Infisical maintains a catalog of supported resources, including PostgreSQL, MySQL, and Redis databases, Kubernetes clusters, and SSH servers, along with the accounts that can be accessed. Users see only the accounts and resources they're authorized to access based on roles and policy. They don't need to know connection strings or credentials. Next is connection. Using the CLI or a web launcher, a user selects the resource and account they want to connect to. They authenticate as themselves, and Infisical brokers the connection, injecting the underlying credential on their behalf so the user never sees or interacts with it directly. They just authenticate as themselves. When the connection is initiated, Infisical routes the connection through its gateway architecture. A lightweight gateway agent runs inside your private network. It does not require inbound firewall rules. Instead, it establishes an outbound connection to Infisical's relay service. When a user connects, traffic is securely routed through the relay to the gateway, and then to the target resource. Your infrastructure is never directly exposed to the public internet. And at the moment of connection, Infisical injects the appropriate credentials automatically. Those credentials can again be dynamically generated and short-lived. The user never sees the password or the private key. They simply get an authenticated session. Finally, monitoring. Each privileged session can be logged, and logs are searchable. Database queries, kubectl commands, SSH activity, all can be recorded and stored securely for auditing, compliance, and review. Access becomes identity-bound, time-bound, and fully observable. Instead of distributing infrastructure credentials, you centralize control over how they're issued, used, and audited. Even though users never see infrastructure credentials, those credentials exist underneath. Database accounts, service accounts, privileged users tied to systems. Infisical can automatically rotate credentials for supported PAM resources on a defined schedule. That means the underlying passwords or keys backing privileged access are updated regularly without breaking user workflows. And because access is brokered through Infisical, rotation happens transparently. Engineers continue authenticating as themselves, while your infrastructure credentials change behind the scenes. This ensures that even privileged accounts do not become long-lived attack surfaces. Privileged access should not be permanent. Infisical supports just-in-time access policies, where access is granted only when needed. Users can request access to a specific resource or account. That request can require approval before the session begins. And access can be limited to a defined time window, whether that's minutes or hours. When the session ends or time expires, access is automatically revoked. This enforces least privilege operationally. Instead of standing admin access, privileges become temporary, intentional, and governed. When you step back, secrets, certificates, and privileged access management aren't separate security categories. They're different surfaces of the same underlying challenge: controlling identity and trust across infrastructure. Secrets govern sensitive values used by applications. Certificates govern cryptographic trust between systems. Privileged access governs how humans interact with live infrastructure. In most organizations, those are handled by different tools, different teams, and different policies. That fragmentation creates blind spots. Infisical brings them into a centralized control plane. One platform to issue, manage, audit, and rotate credentials, whether they're secret values, X509 certificates, privileged access sessions. It's open sourced and self-hostable, so you can run it inside your own environment, or you can use Infisical Cloud. And it's built for developers with a CLI, SDKs, Kubernetes integrations, infrastructure as code support, and an intuitive dashboard. If you want to explore it yourself, you can get started at infisical.com. It's free and open source. You can browse the documentation, explore the GitHub repository, or spin up your own instance and see how it works in your environment. Links are in the description. Thanks for watching.